Welcome back. Today we are going to look at constraint random vector generation. So constraints are basically limits on what value a given variable can take. Normally when we use the default random function which is available in Python, it generates all the values within the domain of values that is specified for it. For example, if I say random.randit from 0 to let us say 1024, that it can generate all values from 0 up to 1023. There is no way in the random function for me to further optimize the values that are selected based on some other value which is set somewhere else in the design. For example, if I have some value x, y, and z, I cannot say that z's value should be, let us say, 0 to some number x and then y to 1500, and where y is random and x is random. So relationship between values are difficult to specify with the default random function. And this relationship between different variables are typically specified in the protocol specification. Then there will be additional such constraints which will be defined in the architecture or design specification. And finally, when we are writing out the test plan, we might further refine this constraint in order to hit specific goals. So to take an example, if we look at the Ethernet specification, an Ethernet packet consists of an header and a payload. Now the header could have a field called as VLAN tag, and if it has a VLAN tag, the size of the entire header field is 16 bytes. If it does not have a VLAN tag, the size is only 14 bytes. So that is given over here as our specification. Now there is another field called ether type in the header, and this field can take a value between 800 up to 0xff. If it takes a value below hex 800, it is called as length field. And then packets with ether type of 806 have a size of 64 bytes. Default packet length varies between 64 bytes and 1500 bytes. And you have n number of other such constraints for different packet type, for unicast, broadcast, multicast. Then you might have constraints on your source address, destination address based on some routing algorithm that you're using. Now, if we want to verify an engine or a DUT which takes an Ethernet packet, our first option is that we randomly generate different values, all these values of say header, payload, VLAN tag, ether type, and then using a bunch of if-else condition, see whether the generated value is valid or not. And if it is not valid, discard it and generate a new value and use that. That's option number one. Or else we put a large for loop, so a multi-dimensional for loop, which says for header length between 16 and or for VLAN tag between true and false, ether type from 800 to all the possible ether types, and then packet length from 64 to 1500, and then start putting our if-else condition in this multidimensional for loop to decide whether the generated packet would be valid or not. And if it is valid, then add it to our list of valid packet or return it if we are a generator. So that's one way of doing this. And while in some cases this method of generating our packets might be optimal, one problem which we get is that if at a later date we decide that we want to add one more constraint, we will have to go and modify our packet generator class. And now after running our regression, if we decide that we want to run test cases with specific ether types or specific ranges of packet size, it will be difficult to go and modify our generator class to only generate those packet types. We might have to pass additional parameters, and that will quickly become messy if such constraints are very huge or very large. The other option which we have is use our generator class as it is, take the output of the generator class, and then filter it based on whatever conditions we have. The third option which we have is build a class using this generator class as our base class, and then in this base class do all the filtering and then return the values whenever we are getting a value from the generator class. There's a different method for doing the same thing, and that is using something called as Python's constraint class. So what Python's constraint class does, for example, right now when we spoke of using random, our code ended up with for loop and lot of if-else condition and maybe classes deriving other classes or external functions trying to filter out the values. So it starts becoming a huge mess. And that's the place where the constraint class comes in. It tends to have a one-to-one correspondence with our specification. So if you look at our Ethernet packet specification, each line over here would result in one line of constraint. And if at a later date in our test case we wanted to further constraint this class, we don't have to subclass it or do any filtering on the output or go ahead and modify this. We can directly add that constraint on our instance of the class, and that will now generate values with the new constraint. So while constraint based generation might take a longer time, it tends to have a cleaner code base and it is more extensible. So let us take a look at a simple example. Let us try to put a constraint for our Ethernet packet generator. So this is the list of our constraint. Now what we'll do is we'll import. So the constraint package, when you have to install it, you need to say remember the package is installed as Python constraint, but while we are importing, we just import constraint. So we have imported the constraint class. Now class, we have defined our packet generator. And in our initialization routine, we will now start adding our constraints. So constraint has a subclass called problem. And now we say p dot add variable. And we'll start listing out our variables are header length. And header length can take a value of either 14 or 16. Then add variable payload. And payload can take a value between 50 to 1500. less than 1500, but let's keep it at 1500. Next we have length, and length can take a value from 64 to 1500. And finally, let us say type. Type can take a value from 800 to, and also we have VLAN type. And this takes a value of either true or false. That is either the packet has VLAN or does not have VLAN. So now that we have added all the constraint variables to our solver, we'll start adding our constraints. Add constraint. And our first constraint is on the header. So header would have size of either 16 or 14. So that is accounted for. Now a packet consists of header and payload. So our length field, header field, and payload field. So our length is equals to header plus payload. So that's our first constraint, that a packet consists of header and payload. And the input it is taking is length, header length, and payload. Our next constraint is regarding VLAN tag. So we are checking whether it has VLAN, and based on that we are constraining the header length. Header length equals to 16 if VLAN, else header length equals to 14. And let us add the mapping for these two variables. So VLAN has VLAN, and header length is header length. So basically, when we are defining constraint, what we are doing is we are mapping this variable maps to this variable maps to this, and this in turn maps to the variable we have defined over here, has VLAN is this, and header length maps to this. So this is the map in which we are doing. So when we add a constraint, we are defining a lambda function. So here we are defining a lambda function with two variables, VLAN and header length, and then operating on these two variables. And then the next parameter that we are doing is the mapping between the variables of the lambda function and variables of our constraint solver. So let's move on. So we have covered header length, we have covered this. Now next is ether type. So ether type we have already said that it takes between 800 and this. If we give this, it will try to generate all combination of header length, payload length, and this, and that will take quite some time to generate. So we will restrict our ether type to just the first 10 ether types. So p dot add constraint lambda ether type and ether type is less than or equal to 0x 810. This is our constraint and the field it is type. This is the constraint we are putting on our type field. And finally, we have a constraint on a specific ether type that for this ether type, the size will be 64. So let us add that. So length equals to 64 if type is equals to 0x806. Any length is possible. So, and here we have length and type. So we have defined our constraints. Now let us solve our constraint. So this will return all the solutions. And finally a getter function. So now this getter function will basically select a random value from all the solutions which are available. So what it is going to do is random dot trace. And with this, we have finished defining our generator class. Now let's test it out. So we'll do it in this file itself. So our first option is let's go to packet generator. Then pkt.solve and let us print out the first 5 values. And I believe this should complete our implementation. So let us just test it out. Here we are, and I forgot the comma here to see what else. So it has generated different packets. So header length 16, header length 14. So wherever it is header length 16 has VLAN as true. Where has VLAN is false, header length is 14. So this constraint is being maintained. And then length is all over the place from 598, 596, 1000, 1400, 1200. And if we add up header length and payload, that should give us our length field. And then again, type is all over the place. So now let us try a few things. Let us say that we want to constrain our type to a specific value. Let us say this, we are writing a new test now. And in that test, when we do the generation, we want the type to be 806. So we end up saying packet dot. There are two ways in which we can do this now. Either I could directly call p dot add constraint and add my constraint over here, type field, and say type is equals to 806 and give type as my. So this is one way in which we could do this. The other way in which we could do this is we could define a add constraint function which takes into function and map, and then from here also dot p dot add constraint function and whatever mapping is provided. So this is another way in which you could do this. Right now we are going with this approach where we have added this constraint and then we are solving for this and generating and applying it. So now in this case the type is always 2054. Did I make a mistake? Yes, I made a mistake in my code. I have interchanged my type and length field. So length type, this should match the definition over here. So with this, let us try again. And now my length is always 64. And in this particular iteration was always false, which resulted in header length being 14. Let's try once more. The problem which we had was over here with payload, we have defined it as 50 and length is payload plus header length. So the only way you can get a length of 64 is if you do 50 plus 14. So if we change this to 48, we should see both values. So we have two cases in our solutions. Has VLAN is true and has VLAN is false. And based on that, header length is either 16 or 14. Okay, so that's our overview of the constraint package in Python and how it is used in our code for generating constraint random vectors. Thanks for listening. Bye. Have a nice day.